So students, we started our chapter with the definition of the work, and then we did the concept of work energy theorem, and then we did the work done by the variable force, and after that we did, so this is the work done by all forces, and frequently we keep on using this concept that net force is equals to m into a, and this is the work done by all the forces. Then we did what the kinetic energy is. So kinetic energy is equals to half m v dot v, that's equals to half mv square, and it's always positive. Then we did the concept of potential energy. Potential energy is the concept that is linked with conservative forces. So we define potential energy only for the conservative forces. This work energy theorem, it is for all sources. Means your Fg, your spring force, which are conservatives, as well as non-conservative, your friction force. So work energy theorem is for all the forces, but concept of potential energy is only for the conservative forces. And what this concept is? The concept is that whenever I do work against the conservative force, like this is my earth, and or let it be the surface, and I am raising this ball to height h. So I am doing the work, so gravitational force was acting in this direction, but applied force was acting in upward direction. Students, these two forces are exactly same. They are in opposite direction, but their magnitude is exactly same. And vectorically we will write that like this, because the direction is different, so that is why this negative sign. And this work done by external force was stored in the form of, so work done by external force was stored in the form of potential energy, and work done by gravitational force was exactly negative. So work done by gravitational force was equals to negative u, negative the potential energy. And if this is 0 and this is height h, so change in potential, so initial potential energy was 0. I am taking here it is 0, and over here it will be mgh, so that's equals to mgh, and this is equals to minus mgh. So the potential energy is due to the position, or you can say the configuration. Now how comes the kinetic energy? When I will leave this ball unattended, this ball will come down, and this potential energy is converted into kinetic energy, and the sum of potential energy plus kinetic energy over here and the sum of potential energy, kinetic energy over there is mechanical energy, and that is constant. That is the whole concept of conservative forces. So how do we get this kinetic energy? This potential energy was converted into kinetic energy due to the gravitational force. So conservative forces act in the direction of reducing potential energy of the object. So that is the direction of conservative force. That the direction is always in the direction of reducing the, like here, the potential energy was reducing. So that's the direction of conservative force, that is gravitational force. Now we have a question that this pendulum is at rest. Okay, fine. So now that's an MCQ in our book, which is on page number, what's the page number? The page number is that's question 24 MCQ, question 24 MCQ, page number 6.60 SL. So the question is, the simple pendulum hanging freely at rest is vertical because why it is hanging freely at rest? Why it is at rest? So it's the position that I am talking about. So whenever I am talking about position, it means I am talking about the potential energy. And potential energy stored is converted into kinetic energy by the act of conservative force. So here it is hanging freely and it is at rest, it is in equilibrium position. Equilibrium position. Why? Because its potential energy is minimum over here. The potential energy is minimum at this position, and we also take potential energy as zero also over here. Potential energy can be negative also.
Sir, what is equilibrium?
Equilibrium means that the body is, it's not moving, it's at its place. Equilibrium. We have equilibrium in chemical reactions also, like forward and backward reaction. When the content of when anything is stabilizing, when there is no dynamic thing is going on, means there is no change going on. So then I say that the things are in equilibrium. So it is, so whenever we have this thing, it means due to the position. So it is due to the potential energy. So always think of position, equilibrium in terms of potential energy. You will also say that kinetic energy is zero. Okay, fine. But position, potential energy. Okay. Now we have question 6.3 in the NCERT. We have just discussed that mechanical energy is equals to kinetic energy plus potential energy. This is always positive. Potential energy can be negative or can be positive. But K is always positive because the formula of K is half mv square. So square of V positive, mass is also positive. So that is why K is negative. Now, if we look at the question in our book, so these are potential energy functions which are given to us. So we have only two things. One is this mechanical energy and one is potential energy. So these two things are there in the figure. And kinetic energy will be, what will the kinetic energy? Mechanical energy minus potential energy. So this thing should be positive. It cannot be negative. So if it is negative, then that particular potential energy function is not possible. So that's what we have to tell, that we need to specify the region in which the particle cannot be found for the given energy. So particle will not be found. Particle will not be found if kinetic energy is negative. So that's what we need to see. Look here, at this point, this is the mechanical energy, and potential energy is greater than mechanical energy. So what will be the K? Will the K be positive or will the K be negative? Yes. Will the K be positive or negative? So we need to tell the region where the particle cannot be found. Particle does not exist. Particle not found. And then also we need to indicate the minimum total energy of the particle must have. So minimum total energy of the particle must have in each of the case. Okay. So students, here this is x, this x-axis position, this potential energy, and this potential energy function, this origin. So x equals to increasing, and I reach x equals to k. So this portion means x is less than a, and this portion means x is greater than a, and exactly at this point x equals to a. So what about x less than a? X less than a, you have no issues. But x greater than a, at this point the potential energy is greater than, so if the potential energy is greater than kinetic energy, then what will happen? This K is equals to E, which is lesser, and U greater. So the answer will be negative. So this thing cannot exist. So it means that the particle will not found in this region, because here kinetic energy comes out to be negative. So what is the minimum total energy particle must have? So minimum total energy particle should have is how much? Is 0. Minimum energy Next case, this figure. So this was figure A, now figure B. So in this figure, you can see that this is my mechanical energy, this is the potential energy, so always greater. So what does this mean? So particle will not exist in the region when x is less than a, and when x is okay. So look at this figure. I was started discussing this figure. We are looking at this figure only. So see here, from infinity, minus infinity to plus infinity, at all the points, your potential energy is greater than kinetic energy. And as a result, potential energy is greater. So this is greater than this. So E is lesser. So it will again be negative when the x is between minus infinity to plus infinity. So particle will not be found in any region from x equals to minus infinity to x equals to plus infinity, because kinetic energy will be negative. So and what is the minimum energy that it should have? This is V1 over here. So this is the minimum energy of the particle. So here the minimum energy was 0. You can see. Yes. But here the minimum energy should be V1. So particle must have at least this much of energy. Even kinetic energy is 0, so this much of energy is required. So minimum energy should be V1. Now C part. Look at, so this is your मेरे को प्यारा मेरे को प्यारा मैं सुबह शाम रात को दिन. So now look at figure C. In figure C, we can clearly see that E is, so students, you just need to see that this E must be greater than the potential energy. Then only kinetic energy will be positive. And if E is lesser, so see the points where E is lesser. Look, here, this is U is greater than E. So particle will not exist in this region. Yes. Now what about here? Here this is your E and this is your U. So yes, particle will exist here. Okay, what about here? This is your E. So E is greater than U. So K will be positive. So it will exist here. But what about this position again? Here again, U is greater than this. This is your E. So U is again greater than E in this region when X is greater than B, and when X is lesser than A, again U is greater than E. So particle cannot exist in this region. This is not possible. Okay. So the particle will not exist in the region when x is less than a and when x is greater than b. Now what is the minimum energy? You can see here the minimum energy is, so minimum energy means least potential energy. So what is the least potential energy in this case? This is negative V1. Now fourth part, look, this is your E. So in which region E is greater, there exists the particle, and where E is lesser than this U. So potential energy has two symbols, U and V, but we are preferring the symbol U, okay, the letter U letter instead of letter V. So now here in this region, from x equals to minus b by 2 to x equals to minus a by 2, in this region potential energy is greater than mechanical energy, so which tells that kinetic energy will be negative, so it's not possible. So particle will not exist in the region from minus b by 2 to minus a by 2 in this region, because in this region from here to here potential energy is greater than E, and which means that kinetic energy, which is E minus U, so E is smaller and this will be negative. And that is why particle cannot exist in such regions. Now here V is lesser than E, so that's all right. So here particle exists. And what about again here U is greater than E, so particle will again not exist in this region. So particle will not exist in this region also and in this region also. So that's because of this reason. So it will not exist from a by 2 to b by 2. Now what is the least minimum energy given here? That is minus V1. Okay. So that was this question 6.3. Now students, let us just proceed with something new today, and that is we know that for the conservative force, E is equals to K plus V. We just did it, and this is constant. So therefore any change in kinetic energy plus potential energy is 0. You can also write it like this. So net change in kinetic energy and potential energy will be 0. If kinetic energy increases, then this will be decreased, then only it can be 0, no? Because one is supposed to be positive, other can be negative. So then also it will cancel out and comes the 0. So this was for the conservative force. Now what if we have the force of friction also? So we have conservative force and this friction as non-conservative force. So what will be the mechanical energy formula in this case? So we need to modify this formula. So what will the formula if we have both conservative, non-conservative forces? We know that work energy theorem is applicable for work energy theorem is applicable for both all kind of forces, whether conservative or conservative. So by work energy theorem, work is equals to change in kinetic energy. And what is the work? I told you that it is the work by all the forces. So let us combine all the forces, conservative and non-conservative. And delta x is the displacement, and that's equals to so what will come here? Let us see what is Fc into delta x. Conservative force, work done by conservative force, that is equals to minus u, and now what will this work done can further be written as delta k plus u is equals to, for non-conservative force, this delta x. So I don't know. So it was 0 for conservative force, right? But for non-conservative force, this will be equals to non-conservative force into delta x. And we can write that change in E, so mechanical energy will change, and that is equals to NC delta x. So that is for the non-conservative force. So for conservative force, delta E was 0. What is delta E? Delta E means k plus u. So that was 0 for the conservative force, but for non-conservative force, there will be change in mechanical energy, and that is equals to force into displacement, that is the work done by non-conservative force. So that's the change in the formula. So it depends on the, that depends on the path. Non-conservative forces, the work done depends on the path. Now next topic we have is various forms of energy. So what are the various forms of energy we have? This is page number 126. So energy due to motion, you already know kinetic energy. Due to position, you have potential energy or the configuration. Now energy is conserved. It just transforms from one form to another. And we even don't know that which way it is changing into which. So we need to have the knowledge of the kinds of energy. And we have already studied them also, like heat energy. So students, read this topic from NCERT. It's not that difficult at all. So, but this is very important. Easy but very important. And you will find a lot of new things that you don't know. Like when I'm sliding this box on a surface which is rough one and it has some friction force, so this is where the force is applied. So friction force is always in opposite to this direction. And it moves some distance. And we can see example 6.5 also. So in example 6.5 in your NCERT, the woman was pushing a trunk on the railway platform, and which had a rough surface. So that question, if we extend that question, so mass m sliding on this rough friction with velocity v0, with speed v0, and it comes to a halt over a distance x naught. So it stopped at distance due to the force of friction. So work done by the force of kinetic friction over this displacement is given by force is equals to, so displacement was in this direction, force of friction was in this direction, so obviously minus Fd, so minus F into x naught. So that's the work done by the frictional force. Now by work energy theorem, we have just studied that the work done, that is change in energy. So, and by work energy theorem, this work will be equals to change in kinetic energy. And what is change in kinetic energy? So what is change in kinetic energy here? Let us write it separately. So kinetic energy is equals to half m v naught square. So that's the change in kinetic energy. Because this is initial kinetic energy, this is final kinetic energy. So change in kinetic energy is equals to final minus initial, and the final was equals to 0, initial was equals to minus half mv naught. So kinetic energy cannot be negative, but change can be negative. So the change can be negative. Now the work energy theorem, work done is equals to kinetic energy. So this gives me half mv naught square is equals to f x naught. So it means that the kinetic energy, as it comes to a halt, so the kinetic energy that it was carrying is gone. Where has the kinetic energy gone, students? There is no kinetic energy over here. It is 0. At this point, Kf is 0. So where has this kinetic energy gone? So we are finding the work done due to force of friction, and friction is non-conservative force. So energy can never be destroyed. In which form this kinetic energy was transferred? So in which form it was transferred? If I am throwing a ball upwards, okay, ball also comes to a halt over here. Yes, ball also stopped at this point, and then it will come down. So ball comes to a halt. Here I had kinetic energy, but here you are talking about the gravitational force, which is conservative force. So this whole kinetic energy was converted into potential energy, right? But here also the kinetic energy was there, and it comes to a halt. So what this kinetic energy converted into? This is the way this is dissipated in the form of heat. This box is not, the energy was not added to the energy of the box, but here it was added to the energy of the object. But here it was dissipated, lost in the form of heat energy. So keep on rubbing your hands, and your hands will get hotter. So because this kinetic energy was converting into heat energy, so their temperature will increase here. So heat energy, yes, it has gained some heat energy, some of it. So its temperature will little bit increase, and the temperature of this surface will also increase. So even the air, so some of the heat is lost into the surroundings also. And so the work done by friction is not, why I have lost in the sense is that I can't do any more work with it, but actually energy can never be destroyed. It is not lost, but it is transformed from one form to another. So it is transformed as heat energy. So students, here in case of conservative forces, kinetic energy was converted into potential and potential converted into kinetic. But here, in case of dragged forces, this kinetic energy was converted into heat energy. And this raises the internal energy of the block and the table. So now the molecules in this block are moving with more speed. So that's how the energy transformation takes place. Now let us talk about next form of energy, which is chemical energy. So chemical energy, we can, in the fuel, you can ignite the fuel. Yes, because fuel is storing the chemical energy. What if you rub the two stones together? They also get heat up, and you can ignite a heap of dry leaves which is carrying chemical energy. Matchstick also ignites to a bright flame when we struck it against a specially prepared chemical surface on the matchstick. So the lighted matchstick, when we apply it to a firecracker, spectacular display of sound and light is there. So chemical energy arises from the fact that the molecules which are participating in the chemical reactions, they have different binding energies. So a stable compound has less energy than its separated parts. And a chemical reaction where we have rearrangement of atoms. And if the total energy of reactant is more than the energy of the products, heat is released. And the reaction is exothermic. And if reverse of it, then the reaction is endothermic. So chemical energy is associated with the forces that gives rise to the stability of the substances. And these forces bind the atoms into molecules and molecules into the long polymer chains. So we harness a lot of chemical energy of the coal, cooking gas, wood, petrol, diesel, and we harness their chemical energy in our life, indispensable to our life, to our existence. So next is electrical energy. Even the chemical energy stored in the food you eat food, there is chemical energy in it, and that is converted to when your muscles need energy, muscular energy. So whether it is inside your body, slow combustion is going on, or outside, chemical energy is everywhere. Electrical energy, electrical energy quite well, electric current, and that electric energy is causing the bulbs to glow, fans to rotate, bells to ring, and the electric energy governs the laws of attraction and repulsion of the charges, means electric force and the current. Okay. Now, next is equivalence of mass and energy. So that's quite important. So can the mass be converted into energy? So Einstein showed that mass and energy are equivalent and they are related by this formula. E is equals to mc square. Very important formula, students. You will need it in class 12th also. So m is the mass lost in a reaction and c is the speed of light, that is 3 into 10 to the power 8 meter per second. So E is the energy released if this much mass is lost. So the energy released. So this much mass is converted into the energy. So if we have 1 gram, even 1 gram is, so 1 gram is equals to 1 gram is 10 to the power minus 3 kilogram into 3 into 10 to the power 8 into 3 into 10 to the power 8. See, this much joules of energy you get even when 1 gram of matter is lost. So see, this is 10 to the power 16 and 10 to the power 13. So 9 into 10 to the power 13 joules of energy is. And what about 1 milligram? 1 gram is a tiny piece of paper. And what about 1 milligram? 1,000th part of a gram. Even that mass can be converted. Means 1 milligram of mass can be converted into 9 into 10 to the power 10 joules of energy. See how much is this joule of energy. So huge amount of it. So mass energy equivalence means mass is converted into energy. Nuclear energy, so nuclear energy is the energy which is there in the nucleus, inside the nucleus, and that is related with this formula E is equals to mc square. So in 12th class we have a chapter where we'll do all these things in detail. We have the chapter nuclei, especially one chapter is dedicated to the nuclei. So name of the chapter is nuclei. So see how much in detail we are going to do it. So what happens is that, students, let me give you a very simple example about this mass lost. I also call it delta M, that is mass defect. And that is actually the binding energy of nucleus. See, hydrogen has 1 proton and 1 electron. And suppose we have deuterium whose mass is 2, so we have 1 more neutron. So take the mass of 1 proton, isolated proton, and mass of 1 neutron. So that is, suppose x. X is the mass of 1 proton plus 1 neutron. Now mass of nucleus of hydrogen, deuterium hydrogen. So this is y. So obviously these two are supposed to be same, but this is lesser. The mass of nucleus is lesser. See, this is simply, nucleus has 1 proton plus 1 neutron in the deuterium, and I have added isolated mass of isolated proton and isolated neutron, that is suppose x. But the mass of nucleus, when So I have one proton separately and one neutron separately, and I have found and I have added their mass. But when they are nucleus, here the mass is lesser. So where has the mass gone? That is mass defect. So delta M is equals to x minus y. So that mass is actually binding these nucleons, binding the subatomic particles. So we better understand it when we do it for carbon atom. So 12 protons of carbons, mass of 12 protons of carbon and 12 neutrons. So 6, so total is 12, 6 protons, 6 neutron, 12 nucleons. So atomic number of carbon is 6, so it has 6 protons. So when you multiply mass of 1 proton into 6 and mass of 6 neutrons into the mass of 1 neutron, you get the mass. And but this is but the mass of nucleus, which contains nucleus of carbon, which contains 6 protons, is lesser. So this is lesser, that is mass defect, and that is this difference is the source of energy. So this mass defect is equals to mc square. So this mass defect can be written as delta E by c square, right? So E and c square will come this side. For chemical reaction, this mass defect is much smaller. Now we have example 6.10. So we have the tables and express means different energies are expressed in table 6.3. You can see even in table 6.1 we have different units of energy. In table 6.3 we have the energy associated with various phenomena, and we have table 6.2 also, which is on page number 118, and it also has the energy, kinetic energies, energy due to motion. So now the energy required to break one bond in DNA is electron volt. So electron volt, you know how small this unit is. The kinetic energy of an air molecule, so A part, so we have to express the energy required to break one bond. So that's equals to 10 raised to power minus 20. So where do we have this energy to break one bond in DNA? That is in table 6.3, last line. Energy to break one bond in DNA is 10 raised to power minus 20 joules. So that's 10 raised to power minus 20 joules from table 6.3, last line. And now we want to change it to electron volt. So we know the relation that 1 electron volt is equals to 1.6 into 10 to the power minus 19 joules. So how much is this in electron volt? So you can also write it that 1.6 into 10 to the power minus 19 joule has 1 electron volt. So unitary method. So 1 joule will have how much? 1 divided by 1.6 into 10 to the power minus 19 electron volt. And what about 10 to the power minus 20 joules? So that will be 1 upon 1.6 into 10 to the power minus 19 to 10 to the power minus 20. So now minus 19 minus 10 to the power minus 1. And this comes out to be 1 upon 1.6 into 10. So do it and you will find that this equals to minus 0.66 electron volt. So you can do it with the unitary method, students. Now again, so these are very small energy, so it's better to express it in the smaller units, and this we can write it as in electron volt also, in milli electron volt. So how to change it in milli electron volts, students? Chain rule. I want to remove this EV, okay, and I want to bring mega electron volt. So milli, sorry. So what is the relation between 1 electron volt has 10⁻³ electron volt, 1 electron volt. So that's equals to 60 milli electron volt, right? You can go back by replacing milli with 10⁻³ and we'll go back to this. Okay, so energy conversions. So similarly you can convert 10 power, if it is 10 power minus 21 multiplied with 10 raised power minus 21. Okay, so that will comes out to be 6 milli electron volt, because 10 is for 21 here, so 0.006. So that's B part. Now you have to convert daily intake of human adult 10⁻⁷. This is the total energy that we take in a day, and change it into calories. So simple, the conversion from table 6.1, 1 calorie is equals to 4.186 joules. So I want to change it into calories. So again unity method, so write this calorie here, okay, I want calorie here. So 4.186 joules has 1 calorie. So 1 joule has 1 upon 4.186 calories, and 10⁻⁷ joule has 1 upon 1.486 into 10⁻⁷. So that much calories are there, and this will be 2.4 into 10⁻⁶ calories. And you can write it in the form of kilocalories also. So how to change it in kilocalories? So write it like this, okay, and 2.4 into 10⁻�3. So 10⁻³ means kilo, okay. So simply write it kilocalorie, and that is equals to 2400 kilocalories. So it means now we have principle of conversion of energy that we have already studied, that total mechanical energy of the system is conserved, the force doing the work on it are conservative. But if non-conservative forces are involved, then part of mechanical energy may be transformed into heat, light and sound. So total mechanical energy will not be converted. We have just did in the case of friction. And sometime if kinetic energy is higher and lot of friction is there, then you can also see the light, some sparks, and along with the sound also. But however, the total energy of an isolated system is constant. So energy can neither be created nor be destroyed. It just the total energy of the universe is constant. If we are taking universe as a isolated system, so it's constant. Now the last topic of today, that is power. So power, see, we studied work. So both the motors are doing the work, raising the water to the 1000 liter tank in your home, but this motor is 1 horsepower, 1 HP, 750 watt. That's the unit of power. Another motor is of 2 horsepower, that is 1500 watt. So suppose if it is filling the tank in 10 minutes, it might fill it in 5 minutes. So work done is same, but it is doing the same work quicker. So that is what power is. So work done is same, but who is taking lesser time? So lesser time means more power. So that will be the formula of average power, isn't it? Now, what will the formula for instantaneous power at a particular point of time? That will be dW by dt. Now, put the formula of work done here. What is work done? d by dt of F dot R. If the force is constant, and that will be equals to, so power is equals to d by, so this F is constant, come outside, and this dot will also be there. Here we have the dot for the R, because there is R is changing displacement, and that's equals to F dot V. Students, this is a new formula for you.
So what is R?
R is the displacement, position, change in position, dr by dt, change in position. So if I am lifting the water up, so it was here and its position is changing, so this dr, this displacement dr. So R is this dr is change in position. R is the displacement in the formula. Work done is equals to F dot D. So I'm writing here D or R, it's the same thing. It's displacement. So what is displacement? Rate of change of displacement. Rate of change of displacement is velocity. So students, the important thing is that this is instantaneous velocity. And here right from the beginning, this is instantaneous power. So instantaneous velocity, so F dot, again a dot product. So students, you will get a question in your exams based on this formula, because you already know this thing, but the new formula is P F dot V. Okay. And we have a example. Let us do this example also. Example 6.11. So we have an elevator, and this elevator can carry maximum load of 1800 kilogram. So of course the mass of elevator plus mass of passengers, both are included. So this should be lesser than this 18,000, this mass. And moving up with a constant speed of, so speed is constant. So speed constant means your instantaneous speed, average, instantaneous velocity, average velocity, everything is same. So we have the velocity, speed here, 2 meters per second. The frictional force opposing the motion is, so we have the friction force in this direction, that is equals to 4000 Newton. Determine the minimum power delivered by the motor to elevator in watts as well as in horsepower. So what is the total force acting? So total force is mg gravitational force plus friction force which is acting downwards. So we have two forces acting downwards. One is the mg, that is gravitational force equals to mg. So total force acting downward is gravitational force plus force of friction. So what is the gravitational force? M into g equals to, so mass is 1800, sorry, let it be maximum, into 10 plus. So here, see, we should take g as 9.8, but if we are taking 10, then it should be given in the question that take g is equals to 10. But okay, let it be like this, plus 4000. So the total downward force is 2200 Newton. Students, I have told you many a times, whether you are doing this kind of question, we know this force, and by this force applied was equal to this force. Even we are rising this ball upward. So this, I told you that both the forces are same. We assume that acceleration is 0, constant velocity, and here you can clearly see that acceleration is 0. That is clear-cut example. So acceleration 0 means upward force is equals to downward force. So upward force is also 22,000 Newton. Acceleration is 0. Okay. Now, this is the upward force. What is the power? This is the velocity. Instantaneous velocity, average velocity, that's the constant velocity. So power is equals to F dot V. So this is the force that I need upward. And with this velocity, so this force and velocity, they are in same direction. So theta is, velocity is also upward, force is also upward, the upward force that I want. So cos 0, so P is equals to F dot V, that is equals to FV cos 0, that is equals to 1. So FV, so what is V? You want 2 meters per second. So what is the power? So power will be 44,000 watts. So that is the SI units of power, students. Okay, remember this thing. And horsepower is, 1 horsepower is equals to 746 watt. So 746 watt means 1 horsepower, and 1 watt means 1 divided by 746. So you want to change it to horsepower, so 1 divided by 746, that will be your horsepower. So students, that's all for today. Thank you so much.